right, everybody, it is 2:30. We're going to go ahead and move on with our next presentation. We have NCAUG's board's very own Jay Fowler, who's going to talk to us today about ArcGIS Velocity. And along with being one of our board members, he's also a solutions engineer at ESRI. So take it away, Jay.
Thank you so much, Nancy. I really appreciate it. I'm monitoring the chat too, so if you have questions, we can definitely get to it. I see y'all talking about St. Paul and the Broken Bones. I got to see them in Charleston, and it was really great. I think it was at the end of Spoleto. So yeah, if y'all get a chance to check them out, man, fantastic show. Cool. Well, thank you guys so much for listening to me today. It's great to talk to y'all. Want to go ahead and just kick it off immediately with a poll. We're like 3 presentations in, keep everybody focused and having a good time. I want to know if you're doing any real time at your organization today. Could be SCADA, could be various environmental sensors like wind or stream gauges, rainwater, could be AVL, could be keeping track of field workers and making sure they're safe. And while that poll's going on, I'll just give you a little bit of information about what I'm going to be talking about today, and that's ArcGIS Velocity. I heard Nancy mention it. I want to know what velocity is. I don't even know what that is. Well, it's great that y'all are here and that we can talk about this. So ArcGIS Velocity is a brand new product. It is real-time and big data processing and analysis, and it's a capability inside of ArcGIS Online. I'll say that again. It's in ArcGIS Online. So this means that it's software as a service, so it's SaaS, and it's also cloud native, and it's ESRI managed. It can work with other cloud services like Azure Event Hub, Service Bus, and also storage like Azure Blob Storage, for instance, and other cloud services as well. So it's a really, really interesting offering. I think as a lot of you guys are probably interacting a little bit more with cloud services. All right, so we can probably end this poll. We see 49% not doing as much interaction with real-time sensors, but 29% saying yes, and then certainly significant portion, 22%, not really sure. So I totally understand that. You know, organizations are large, and there's various groups doing different things, and sometimes there might be a group doing real time and you don't even hear about it, or sometimes you're intricate and vital to the mix. So really interesting poll. Thank y'all for participating. I got 2 more coming up later in the presentation. So stay tuned and keep focused. All right, so, you know, we see more and more governments and organizations having a need for real time and coming into contact with it a lot more frequently. This is for tracking people, tracking vehicles, AVL feeds, analyzing where they've been and what they've interacted with while they're out there, right? This can be used for monitoring operations. This can be for integrating other systems, such as SCADA systems. This can be for ingesting environmental observations like rain gauges, stream sensors, air quality sensors, wind sensors to get the speed of the wind outside and make sure everybody's safe during an emergency, for instance. All of this to gain situational awareness and take action. So open cases to close roads or pull people back in from the field, notify stakeholders with an email, all through kind of data-driven decision-making processes related to real-time data. All right, so as connected devices continue to become more and more prevalent, the need to manage and analyze this data is definitely growing. It's a lot of data, right? It's big data. So it consists of hundreds or thousands of observations, and the data is coming at you or your organization at an unprecedented speed. So it's no longer observation in the morning and an observation in the afternoon. These are like every minute or every 30 seconds, new observations coming in, and then you multiply that by the number of sensors you have. So the data is coming in at unprecedented speed. And because of that, it can sometimes be difficult to kind of cut through the noise to gain actual insight or detect patterns to make those data-driven decisions. With that, building systems that can take advantage of high volume, high velocity data can be challenging. These systems need to be highly available, They need to be scalable, they need to be resilient, and they also need to be easy to configure and maintain over time. Often this goes beyond the scope of traditional on-premise solutions because of this huge need to scale. So Velocity, deploying real-time and big data analytics in the cloud, in this case, ArcGIS Online, you can access all this power needed to handle the higher volume, higher velocity data and scale very easily. All right, so ArcGIS Velocity enables 4 fundamental ways to use real-time data. The first is that you can ingest this data being broadcasted by sensors. You can analyze the data to get real-time and historical insight into the data you're collecting. You can trigger alerts as data comes in, as thresholds are met, and you can then take action where necessary. So Velocity is designed to meet these challenges through an easy to use framework for the user. All right, so we're going to hit 2 common questions kind of back to back. Maybe you guys have heard about analytics for IoT. This was about 6 months ago. And the first question is Velocity a new name for ArcGIS Analytics for IoT? Are there any functional differences? The answer is it is a new name and there are functional differences. So about 6 months ago, we had Analytics for IoT. We've renamed that ArcGIS Velocity, and we've added some capabilities. Velocity is an end-to-end system for real time that also supports analyzing data in real time as it comes in near real time with scheduling, and also over time. So Analytics for IoT only provided the ability to do analysis on real-time data. For instance, I have buses driving around. I can create a buffer around those buses. It's an example of analytics on a real-time feed. Velocity, on the other hand, can store and run analytics on real-time data and data at rest. So it's not just happening at real time. You can schedule it to do it later. You can do it ad hoc, but it can do analysis on that data at rest. Velocity can connect as well to external data sources you already have to join in data or run analytics on this data at rest. So if you have a data lake or something like that, you can bring that data in and use the horsepower behind Velocity to do this. All right, our second question. This slide depicts essentially the ArcGIS platform and how Velocity fits in. You can see that it's off to the right there. It has the new logo on top of it. And parallel to the left of that, you see GeoEvent server and GeoAnalytics server. So the second common question is, how does Velocity differ from GeoEvent server and the functionality of GeoEvent server? And that's a really good question. Velocity is real time, but it's also the analytics portion. GeoEvent server is only real-time data, right? It's pulling in this data. It can process it in real time and do something with it, but it's not going to do analytics over time or against historical data. That job was done and is done by a separate server role known as GeoAnalytics server. So you can see the two kind of paired up there. So ArcGIS Velocity can be thought of as the parallel to GeoEvent server and GeoAnalytics server, and it's also in the cloud. It has GeoEvent capabilities for real-time incident detection and alerting, and it has the GeoAnalytics capabilities for the big data analysis. Another key difference is GeoEvent server is on-premise. You install it, you manage it, you do the updates. When I say on-premise, that could be physically in the city, the county, the states, your organization's data center. But it also could be in the cloud. You can install, GeoEvent server in AWS or Azure, but you're responsible for that. You install it and you manage it. Velocity, on the other hand, is software as a service. So it's SaaS. You do not need to worry about maintaining the environment, updating it. It's not on your own infrastructure. It's on ESRI's infrastructure, and it's our responsibility to keep it performant. GeoEvent server, the scaling behind it is limited essentially to the computational resources your organization has, right? It can scale to as much as you can give it. and also as much time as you have to give to it, right? Whereas Velocity can scale across all the cloud computing that ESRI can throw at it, essentially. So Velocity has some really nice abilities to scale overall. So let's do poll number 2. I want to hear about whether you lean one way or another. Do you prefer SaaS-based solutions, software as a service solutions, or do you prefer software that you install and manage yourselves, whether that's on premise or in the cloud? Do you like just kind of going in and configuring something but not being responsible for managing it? Or do you prefer to kind of install, manage the infrastructure behind it, and do the updates? All right, very interesting. While that poll is going on, also let you know that Velocity runs on Kubernetes. It's a container-driven architecture. And this is another way in which it's very scalable. Compute can be distributed across parallel tasks, and it's also resilient because if one of those tasks encounters an issue, it can restart instead of the entire stack needing to be restarted. All right. Thank you all so much for doing the polls. This is wonderful. It's really insightful and fun to kind of see the results. All right, so looking like 65% of the audience prefers non-SaaS-based solutions. Organization installs the software and manages it. 35% prefers SaaS-based solutions. So that's super interesting to see. So thank you guys for participating. We have one more poll coming up, so that'll be exciting. Very cool. All right, so let's talk about Velocity and some of the capabilities it has. So ArcGIS Velocity lets you configure feeds that ingest real-time streaming data. These feeds can connect to cloud IoT platforms, messaging brokers, and APIs that you can access. It can then visualize this data immediately in maps and dashboards. So to compare this, GeoEvent server, you would build out input, build out an output in a GeoEvent service, you output to a stream service, and then you could pull this into a map. And Velocity, when you build out a feed, it immediately provides a stream service. Sometimes that's all the work you're going to do. You're just looking to visualize observations, real-time observations on a map. But as soon as you build that feed, you have access to that stream service. Going to give you a couple examples today of work that could be done with Velocity and real-time data. And we're going to focus on rain gauge and stormwater data coming in real time. Velocity could ingest these readings from rain gauges and stream gauges as the sensors report the conditions on the ground. Velocity immediately produces the stream layer that could be featured in dashboard for situational awareness or a common operational picture. Velocity allows your organization to then provide access or push this data to other partners in the community. So for instance, the state, you could share this data with the state, with counties, with nearby municipalities, maybe downstream, right? With universities who are studying these environmental conditions, and also, of course, throughout your organization. To help with this, you can also leverage these layers and this data in ArcGIS dashboards, apps, the web service, the REST-based services, hub sites, and Hub's open data capabilities. All right, so Velocity also allows you to continuously process and analyze data as it comes in real time, giving you immediate insight into what's happening on the ground. So for instance, an organization could take this rain and stormwater data, stream gauge data, and enrich it or join it to other pertinent data sets on the fly. So these could be other environmental data sets. These could be community demographic data sets, or possibly work zones. For instance, you know, if a certain threshold at a stream gauge requires somebody to do a task or go do some work, it would be really valuable to be able to join in, you know, work zone polygon layer to those observations. So you know who's responsible for checking out the observation. You can also do things on the fly like using proximity and buffers. So creating dynamic buffers, possibly based on water level from a stream gauge. for example. Velocity lets you generate and send alerts when certain conditions or thresholds in your data are met. So organizations could open a case to send someone out to evaluate possible flooding conditions in a community with HTTP call, or create a point in a feature layer that's being used for situational awareness in a dashboard, in a map, in Workforce for ArcGIS, for example. You can make HTTP requests against any system you employ that has an accessible API. So if you have asset management system already, if you can make a call to their API, you could open up a case, for example, there. You could send out emails or text messages to certain stakeholders, or you could do things like if you're using ArcGIS and ESRI's road closure solution, you could put in to close a road. So maybe you set status to close, but also set it to needs review, email a team member that needs to go out and confirm, and then set that road closure to active, for instance, if you're using this system. Velocity also supports batch analytics on large data sets containing thousands or millions of records. This is so that you can understand historical patterns across space and time to get answers that can inform your decisions. Analytics on demand or scheduled. So you can do it ad hoc, you push the button, or you can schedule these to run at a given interval. Big data analytics on IoT data that's stored in ArcGIS or in other big data storage systems like Amazon S3 or Azure Blob can be brought into Velocity and analyzed. And then back to the stormwater example, you could say, are there certain stream gauges that statistically reach a flooding stage more frequently than others? You could do this hotspot analysis and also maybe look at the overall health of your sensors over time to see if there's any patterns or anomalies. Finally, Velocity lets you disseminate this information in whatever way is best suited to your workflows. So you can publish analysis results as feature layers, which can then be easily viewed in ArcGIS maps like a dashboard. You can also write results to external services or store them in big data systems like Amazon S3 or Azure Blob. All right, so let's take a look at a demonstration very quickly. In this video, we're gonna be looking at how a Department of Toxic Substance Control can use Velocity to track vehicles and protect citizens in the community from environmental exposure to hazardous waste. Toxic waste generated at facilities that do lead processing, petroleum production, iron and steel production, and so on. So on the map, you can see we have facilities where hazardous waste is generated and where it can be safely disposed of. And today, this department gets information, high-level manifests of where this waste is leaving and where it's going to. We can visualize this on the map, but it pretty much just shows a line, right? Origins and destinations as the crow flies, but that's not exactly as the truck drives, right? So we can take a look at planned routes as well, but we also know that sometimes there's deviation and we kind of want to know more about the actual routes and where waste is traveling through our community. So now we can see these vehicles carrying hazardous material in real time using AVL sensors and the power location through ArcGIS Velocity. Inside the Velocity web app, we can set up feeds, we can set up real-time analytics and big data analytics, all with a configurable experience. So let's go ahead and check out what a feed looks like when you set it up. We have options to connect with data from ArcGIS, such as a feature layer or a stream layer, from cloud platforms like Azure and Amazon, and also from web messaging brokers like Kafka, RabbitMQ, and MQTT. So here we'll provide some connection information for the feed, things like the address, credentials, and the topic as well of the streaming data. Velocity dynamically and securely connects to the streaming data. It's going to parse it out and it's going to predict the schema. So here we can make changes to the schema. We can remove certain fields, or we can change the field names as well. Next, we're going to identify key properties like location, date and time, and tracking information. And it's really that easy. So at this point, a feed is set up. It's a new item in ArcGIS. Velocity connects ArcGIS directly to your IoT systems and will light up your map with the streaming information. Feed allows you to bring data into your map in minutes without any development staff or architecture. So let's take a look at deriving some insight and taking some action. Part of the mission here is to ensure that sensitive locations such as schools and hospitals are not exposed to hazardous waste. So are these hazmat trucks coming too close to these various facilities? Velocity can help with these monitoring activities. So Velocity is an engine for geofencing, incident detection, and data enrichment in real time and overtime. So this is what it looks like to set up a real-time analytic. We can build out an end-to-end workflow by bringing in data feeds. We can then manage our data with calculations and with filters. We can use proximity and finally output to a layer or send a notification. For our purpose, we're going to take these truck observations and geofence them and measure the distance from schools and hospitals. So the map you see now shows an alert anytime a hazardous truck enters the geofence of a school or a hospital. So let's take a look at what happens with one truck, right? We can see the buffer around this truck as it moves through the community. Anytime that buffer intersects a school or a hospital, we create an alert and can measure the distance in real time. We can then take that measurement and enrich our data with it. We could also send an email or a text alert when the geofence incident occurs. And I really enjoyed just watching this video because it's kind of mesmerizing to see the distances calculated on the fly. All right, so let's go into our third and our final poll. I want to know, what excites you about real-time and real-time data? This slide kind of goes over our answers. Is it creating feeds? Is it the visualizations of real-time data? Is it doing analytics, historical analytics, on-the-fly analytics? Is it doing geofencing and incident detection? Is it alerting, so sending out emails and text messages? You can answer with multiple. You don't have to commit to just one capability. You can choose multiple capabilities. Personally, I really like the visualizations. I love watching that one truck drive around and seeing the distance on the map. And I like the geofencing and incident detection. I think it's really powerful, and I could see how it could be creatively used for all sorts of different purposes. And then all this can go into a dashboard for situational awareness. All right. Thank you guys so much for participating in this poll. So we have we have an overwhelming winner in this one. 74% prefer or are excited about real-time visualizations. And it looks like we have in second place the alerting, so emails and text messages, and then down a little bit more is the analysis. Thank y'all for participating in the polls. I think they're fun. I think it's a great idea to interact during a presentation. All right, so let's take a quick look at how Velocity works. So feeds are the first step in leveraging real-time data and accessing sensors. So that's how you bring the data in, right? So you configure a feed in Velocity. It's an easy to use guided workflow. You can connect to external sources of data like IoT platforms, message brokers, third-party APIs. It's then going to automatically deliver and derive that schema like y'all saw in the video of the data that's coming in. And it's going to allow you to revise that schema on the fly if you need to. And immediately, once that's set up, have a stream service that you can add to a map or a dashboard. Some feeds available in Velocity come from ArcGIS, like feature layers, stream layers, from the cloud, like AWS IoT, Azure Event Hub, Azure Service Bus, Cisco as well, and then some web and messaging platforms as well. Next, you can build out real-time analytics. They provide added value on top of that real-time data that you're bringing in. It's processing horsepower for tracking these sensor workflows. Allows you to build out an end-to-end workflow similar to like Model Builder, for example, to detect incidents, to capture data, to do calculations, field mapping, whatever have you. Real-time analytics process each message as it comes in on the fly from a feed continuously, and it can leverage static data sources for geofences or to enrich various data sets as well. You can combine different tools together in a workflow to ask any number of questions. So you're not limited to kind of one tree trunk, right? You can have multiple branches coming off of that tree trunk. So you can ask a number of different questions and associate different output behaviors. For example, sometimes you might want to store data in a feature layer. Other times you might want to send out an alert or a command to a third-party system. Other times you might want to do both, right? So you have options. Real-time analytics are useful when your decision timeline is operational. So you need to know something immediately and do something immediately. Let's talk about the big data analytics side. So big data analytics can be used to analyze data that you store over time. This can reduce the need to configure and maintain on-premise data centers and keep them optimized. You can run analysis either on feature layers in cloud big data stores that are fed from possibly even existing organizational systems that you have today. Like real-time analytics, you can stitch together different tools in a workflow. So you have an automated process that creates multiple information products at the same time on the same data. That's kind of back to that example. If you don't, it's not just one line, it's not just a tree trunk. You can have multiple branches coming off that to do whatever workflow you need it to. Big data analytics are useful when your decision timelines are tactical. So when you need to make a decision regularly based on standard practices, or when your decision timelines are more strategic. So when you need to learn over time and adjust larger approaches based on historical patterns that you're noticing. Okay, let's talk about how to get started. ArcGIS Velocity is an annual subscription on top of ArcGIS Online. I think I saw a question come through. I'm kind of seeing some of them, maybe about credits. It does not use credits in the way you're used to in ArcGIS Online because it's this annual subscription, right? It's not sold by a number of named users. It's not sold with a credit bundle or something like this. It's just an annual cost that you know and can budget for, and it's on top of your ArcGIS Online subscription. It's managed, your feeds, your analytics are all managed by a web app. It's an authoring environment for the real-time and big data items. And the web app where you set the feeds, the analytics, the big data analytics is only available to creators or GIS professionals in your organization. There's no limit on how many of those can access this web app. But you can set up, the permissions to make sure it's the right folks. So this is where you build the feed in the real-time analytics. Once you have that feed, you have a stream layer or other outputs that are shared. You can share that throughout your organization. If you have viewers in your organization, for instance, a feed of stream gauges could be set up by a creator, but the feed can then be shared out and viewed securely in a dashboard by a viewer user type that has access to it, essentially. ArcGIS Velocity comes in 3 license levels: standard, advanced, and dedicated. Each level adds additional capabilities. So no matter which level you use, you can always create and monitor feeds, perform real-time analytics, and run big data analytics on an ad hoc basis. And I'd say please reach out to your ESRI account team if you're interested in learning more about the licensing levels, capabilities, capacities, and costs, and we can help to right size this for you. Here are a couple of resources. I can put these in the chat afterwards. And finally, in conclusion, I just want to state, Velocity enables those 4 fundamental real-time capabilities: ingesting data, analyzing that data, triggering alerts, and allowing you to take action when necessary. Velocity is a real-time and big data processing and analysis capability of ArcGIS Online. I'll say it again, of ArcGIS Online, making it SaaS, software as a service, and cloud native. It scales really well. If you're interested, reach out to your ESRI account team. Velocity is ready to help your organization do real-time and big data analytics, and we're happy to have that conversation when you're ready. So thanks so much for your time, and happy to take a question or two. I know I kind of came up against time here, so happy to follow up on the chat as well.
Yeah, thanks, Jay. We'll take a couple before we take a break.
Great.
Let's see. Catherine Clifton was asking if the use of feeds like this consume credits in ArcGIS Online.
So I will say the stream service, I do not think it does. You know, in general, Velocity is not like a credit-based system. However, storing data in a feature layer might. That's something I need to follow up on. And I'll go ahead and jot that down and get back with you, Kat.
Okay, and then does ArcGIS Velocity have separate user types and licensing? And also, so the users, well, I'll let you answer that first before the follow-up.
We'll take the small bite. That's a great question. It does not have separate user types. It's to use the web app and set up a feed, you just need to be a creator user type or a GIS professional. Those are the only user types that can set up the feeds, do the analytics setup. But once you have a layer, like a stream layer, you could share that with viewers and field workers and editors in your organization. So there's no add-on user type license, for instance. It's just it's kind of like a blanket product that you add on to your ArcGIS Online. It's a capability you enable for your entire ArcGIS Online organization.
Okay, and is this going to eventually replace GeoEvent and GeoAnalytics on site?
That's a great question. It is not. So we fully intend to have offerings that are server software, non-SaaS software that you install and manage. It's one of the reasons I asked that question. We know folks enjoy both. So there'll be a server side real-time and analytics piece, and then we'll have Velocity as the SaaS offering.
Okay. All right. I'll leave it at that. If you want to answer some of the other questions within the chat, we'll go ahead and take a break. And then at 3:10, we're going to come back and hear from Shannon Martell at City of Charlotte Water about using artificial intelligence to find water meter boxes.
Thank you, Jay.
You're welcome. Thank you.